Alright guys, so today's lesson we're going over absolute value. We've been going over this for a little bit. You should be able to recognize this. This is the absolute value of x. Okay, that's our parent function. Alright, and the meaning of that, we haven't really talked about what that means. The absolute value of x just means the distance from 0. Okay, we're just deciding how far a number is from 0. Okay, so let's go ahead and fill in our table with that knowledge. 0 is 0 units from 0. Alright, 1 is 1 unit from 0. 2 is 2 units from 0. Okay, that all makes sense. Alright, but negative 1 is also 1 unit from 0. And negative 2 is also 2 units from 0. We're just talking about a distance here. Okay, and that's why our graph looks like this. When x is 1, y is 1, x is 2, y is 2. When x is negative 1, y is 1. When x is negative 2, y is 2. That's why our parent function looks like this. Okay? So there's that. Properties of this example. Opens up. Opens means, like, see how it goes like that, kind of? How it opens up this way. If it opened down, it would be down like this. Okay? Horizontal shift, none. This is our parent function. None. Vertex, that's just where the point is. So that's going to be 0, 0. That's right at our origin. Domain, all real numbers. That's everywhere our function is going to be defined. Range, though, is only positive numbers. Okay, because we can only have a positive distance from 0. Okay, and we write that as y is greater than or equal to 0. Alright, this is all stuff you should have known already. The domain, the range, the shape, all that stuff. Alright, moving on. I'm going to try and make this a quick video. G of x equals negative f of x. Alright, what that does is it flips. Okay, that's when our function flips. So, negative f of x, all we got to do is, we're going to fill in this part of this table from up here because it's the same thing. F of x is our parent function, 21012. So, g of x is negative f of x. Okay, all we're doing is flipping the signs on these. Negative 2, negative 1, 0, negative 1, negative 2. And that's going to look like this. Alright, so now all that's different is we open down. Okay, if we open down, we're not shifting anywhere. None, none. Vertex, still at the origin, that's 0, 0. Domain is still all real numbers. And this is the other thing that's going to change. Our range is now everything below 0. So if this is 0 when y is 0, we're under that. We're under our x-axis. So y is less than or equal to 0. Alright, moving on. Alright, so here we're adding k units. That just means when we take our function and add some number. Here we're going to do the example with 2, but you could add any number to this. We could be plus 10, plus a million, it doesn't matter. Alright, so f of x plus 2. Let's go ahead and fill in our f of x. These are all the same as the first one. That's our parent function. Now we're adding 2 to everything. G of x is f of x plus 2. So g of x is f of x. 2 plus 2, 4. 1 plus 2, 3. 0 plus 2, 2. And then 3 and 4. Okay, so everything is just going to be up a couple units. So 0, 2, that's going to be our vertex. 1, 3. 2, 4. Negative 1, 3. Negative 2, 4. So it looks a lot alike. Only difference is we're up 2 units. So everything's going to be up. We're still opening up. We have no horizontal shift, but our vertical shift is plus 2. Up 2 is another way to say that. Alright, vertex, again, we moved up 2, so it's going to be 0, 2. Domain is going to be all real numbers. Our range is a little different. Alright, that's going to be y is greater than or equal to 2. We can look at our graph to see that. Okay, it's everywhere here and up. That's positive 2 and up. Okay, flip it over. We're not doing the second sheet today. Alright, don't worry about that. It's not going to be too long of a lesson. We're just going to do the rest of this first sheet. Alright, now the only thing different here is instead of adding a k, we're going to subtract a k. Alright, so we'll see what happens with that. You guys might be able to guess, but let's go ahead and fill in our original f of x, 21012. Now we're subtracting 4 from all these numbers. We're taking f of x minus 4. So 2 minus 4, negative 2. 1 minus 4, negative 3, 0 minus 4, negative 4, and then negative 3, negative 2. One thing to notice is that we're always going to be symmetric around this. So whatever our vertex is, here at 0, negative 4, we're always going to have negative 3, negative 2, negative 3, negative 2. We're always going to have this match up with this. Okay, let's go ahead and plot these. We're at negative 4, negative 3, negative 2. Okay, looks just like that. Alright, still opening up. Horizontal shift, none. We're not moving side to side at all still. Vertical shift, we're actually going minus 4. So down 4. Down 4. Vertex, 0, negative 4. That's this point right here. Alright, domain, still all real numbers. We can plug anything into this. Only problem is we can't get everything out. Alright, we're actually going to be y is greater than or equal to negative 4. It's everything negative 4 and up. We have implied arrows here. Everything negative 4 and up. Alright, moving on. G of x equals f of x minus h. I know you guys hate to see this, but this is what we got to deal with. Alright, so now instead of having minus or plus number outside of the parentheses, this is actually going to be moved inside. So we're going to have h inside the parentheses. Alright, so let's assume h is positive for this example. We're going to use the number 2 again. So g of x equals x minus 2. This just means that if we let that equal 2, we're going to plug that in inside of our brackets. Okay, so original function, 2, 1, 0, 1, 2. Now we have to do x minus 2. Okay, so negative 2 minus 2, what is that? That's negative 4, right? And then the absolute value of negative 4 is going to be positive 4. Okay, now we're plugging in negative 1 for x. Alright, so negative 1 minus 2. Oh shoot, I gotta change these. Sorry guys. Okay, we're gonna go negative 2, negative 1, 0, 1, 2. Sorry about that. Alright, x minus 2. So negative 1 minus 2 is negative 3. That's gonna bring us up to 3. 0 minus 2 is negative 2. That's 2. Then that's 1, and that's 0. So this is actually our new vertex, is at 0. Okay, so we're going to go to positive 2. That's our new vertex. We're moving up like this. And we can assume that since it's symmetrical on either side, it's going to look like that. Alright, so now we have a new vertex. Alright, we're still opening up. Our horizontal shift is actually plus 2, or right 2. Vertical shift, none. Vertex 2, 0. Domain, still everything. Range is actually back to what we originally had. Okay, it's everything from our x-axis up. One thing to notice about this. Alright, so it did move right 2 in the positive direction, but this is actually says x minus 2. So we got to be careful. If it's in the parentheses like this, x minus 2, x minus 2, this minus 2 means we move right 2. Okay, and we just were able to see why. Alright, let's go down here. We're going to try with a negative h now. Okay, so if we plug in negative 2 for h, we're going to actually get x plus 2. X minus negative 2 is the same as x plus 2. Okay, so 2, 1, 0, 1, 2. Alright, let's go ahead and use these numbers they have here, just for the sake of doing it. What's negative 4 plus 2? We get negative 2. Absolute value of negative 2 is positive 2. Negative 3 plus 2 is negative 1. Alright, absolute value is positive 1. Negative 2 plus 2 is 0. Absolute value is 0. And then 1, and then 2. So now our vertex is at negative 2. We're just going to pop these in there. It's going to look like that. So now all we did was go minus 2, left 2. Okay, vertical shift none, vertex negative 2, 0, domain still the same, range still the same. Okay, so just to wrap things up, if we have in our absolute value, if we have minus, that means we're moving right. If we have plus, that means we're moving left. Okay? If outside of our absolute value, another way we can write this is that outside of our absolute value, we're going to have our function moving down. And same thing here. If we have plus 2 outside of our absolute value, we're moving up. Okay, so it's all about whether or not it's inside or outside. And then if we have a negative, that just means we're flipping. Okay, our graph's going to flip over. All right, that is it. Thank you, guys. We'll do the second half tomorrow.